Hi guys, this is Mike at Akamai. In this short video, we're going to be talking about some of the special features and capabilities which mPulse provides, specifically when used with Ion or DSA as your delivery product. So let's start at the beginning with how mPulse is deployed when you're an Ion or DSA customer. To deploy mPulse, all you need to do is add the mPulse behavior to your CDN configuration. And this actually does three things. The first thing, and this is the one that everyone is aware of, is that it'll have the Akamai Edge server add the mPulse JavaScript tag to HTML pages that are being served from the edge. Now this is the JavaScript tag that is responsible for collecting a wide variety of standard RUM data like navigation and resource timing, page load time, core web vitals, DNS, TCP times, etc. The second thing that the mPulse behavior does is that it activates code in your Ion and DSA configuration to measure and report CDN internal performance data to mPulse. And this data is unique to mPulse and is something that other RUM products just don't have access to. Things like edge timing, origins timing, cache ratios, and CP codes are all made available in mPulse. And then the last thing which the mPulse behavior does is that it works behind the scenes to take the data from mPulse and provide it back into Adaptive Acceleration's intelligence engine, so that adaptive acceleration feature can make data-driven decisions about how to automatically improve the performance of your site. Now we'll review all of these, but let's start by taking a look at some of the special data which the mPulse behavior adds to your mPulse data. Here's a sampling of just a few of the more than 30 data points which the mPulse behavior adds to your mPulse data. The top table shows some of the timers and the bottom table is some of the dimensions. Let's start by looking at some of the timers first. Some of the unique internal timer data that are added are CDN cache hit and cache miss. Basically, was the resource served from edge cache or did it have to go back to origin? If it did have time on the edge, how long did it take on the edge before the response was put out on the wire? If we did have to go back to origin, how long did it take for the origin server to respond? For each of these types of requests, we're measuring not only the main page, but all the resources on the page. And we aggregate those resource types so that you can see the overall edge time and the overall origin time for different types of resources. We also pick up something called client round trip time, which is showing how much time, essentially network time or ping time, from wherever the client is to the edge server that he's connected to, so that you can detect if there's a problem with routing and you're not connecting to the nearest edge server available. In addition to these timers, we have also these dimensions. And what the dimensions do is they allow you to segment the data further to compare different types of data. One of the things that we pick up automatically is the Akamai property version. So whenever we measure a performance of a page, we'll also measure the Akamai property version. And this makes it very easy for you to go back into the mPulse data and look at the different versions of your Akamai property to see how much the change in the Akamai property configuration might have affected the performance. We also pick up different features that you've enabled. Have you turned on adaptive acceleration or front-end optimization? That way you can segment the data and take a look to see which pages had it turned on and which pages had it turned off, and if there was a performance benefit for those pages that had it turned on. In addition to this, there's some things that mPulse wouldn't natively have visibility to, and RUM tools don't generally have visibility to, which is things like what was the HTTP protocol or version used to connect from the browser to the edge server, and what TLS version is being used. However, the Akamai Edge servers have that visibility, so they import that back into mPulse so that you can see that and filter on that in your RUM data, as well as including things such as the ISP that was being used by the customer. Now, this is just a small subset of the available data that's being added in addition to the standard RUM data. For a full list of the data, you can go down to the What's in an mPulse beacon here, and this has actually all the data that's available in the mPulse beacon. There's hundreds of items in here, but if you want to look for just the stuff that's available when available just for the injected from the edge, search for Akamai injected, and this will show you all the other data points that are also added in the mPulse data so that you can do additional deeper debugging with the mPulse data here. So that's some of the stuff that's being added by mPulse. Let's go next and kind of take a look to see what it looks like in mPulse, where you can actually start to use this data that's being added in here. I've got this other tab open to mPulse, so we'll go there now. And I'm going to start here in the waterfall dashboard. Now, the waterfall dashboard has every page view of every user, and for every page view of every user, you can actually see the waterfall chart of the user here. Now, for each page view, you'll notice that if you kind of go down and mouse over these resources, that we have edge and origin timings for each of these resources. Here I can see that this particular page view, this is from somebody in Gibraltar, that he took about 6.92 seconds to load the page. And if I mouse over this first request of the page, I can see that the edge time was 99 milliseconds. So essentially within the Akamai network, the request came to our edge server. There was 99 milliseconds that was spent within our edge servers looking for these resources. Ultimately, we didn't have the resource, so we had to go to the origin to get the resource. And that's where you see that origin time of 262 milliseconds. So for every one of the requests that we have, both on the main page, but also on the resources in the page, we have visibility into how much time was spent at the edge or origin. Here you can see a request that was responded to from the edge. It only took 4 milliseconds, and there's no origin time, indicating that it was handled directly from the edge. And we have that visibility for every one of these resources here. So now we have kind of comprehensive visibility to every request being made for every element on the page that's being served from Akamai, and if it was served from the edge or the origin, and how much time was spent in the edge or origin for each of these. Now, in some of these situations, you may see that we don't collect data on some of these. And let me go down and see if I can find some here. There we go. So if I mouse over this one here, you'll notice that I don't have edge and origin time for these. So what's the reason for that? Well, the reason for that is the way that Akamai passes this data back into mPulse is through something called server timing. It's basically a header on the resources where you can embed timing information. Not all browsers support server timing, and so only those browsers that do support it will be able to see the Akamai edge and origin timings and some of this other additional data. To take a look at all those browsers that do support it, you can see that basically Safari is coming up to speed, but Safari Mobile is a little bit behind, and these will probably adopt in the future here, but you can see which browsers might not have it. So if you see some of that information is missing, you'll know exactly what's going on here. So the waterfall chart is a great way to take a look at individual pages to see what's going on and how much time is being spent at the edge and origin for specific requests from different customers. mPulse also takes this data and aggregates it so that you can take a look at it across a wide variety of pages and see what kind of typical numbers are. I'm going to pull up a CDN metrics dashboard here where we can take a look at some of this data. And for this, you'll see things like the all asset CDN cache hit rate, which is if I looked at all the assets on the page that we are measuring, what percent of them were being hit from edge cache versus having to go back to origin. We also have kind of add up all the time for the CDN edge across all these resources and add them up, how much time is being spent. And for all the time, if you add up all the time going to origin for all these resources, how much time is being spent for each of those. So now you've got kind of visibility for all the assets on the page and kind of how many of them are being served from the edge versus going back to origin. If I go down here, we also have breakouts for each of the different types of resources. Page indicates the base page or the first request on the page, and you can see in this case that the page CDN cache hit rate is 1%. Essentially, they're going back to origin for all of their HTML pages, which is a pretty common setting. If we go down here further, you can see that images are being served from cache, JavaScript is being served from cache, very high cache hit ratios here. Now, the way the data is reported in mPulse here is we're looking at the median page, or a typical page has basically no caching on the HTML page and a lot of caching on the images. If we wanted to look at a slower page and see what's going on here, put this up to the 75th percentile, and what this is going to do is flip the data so that we're looking at a slower page. Now, important to note that the cache ratios here are shown are not the overall across many pages. When I go to the 75th percentile, I'm going to pull up one of the slower pages, the 75th percentile page. And on that particular page, we're going to see what the cache hit ratio is for each of these things. So it's a little bit different from kind of bulk material reporting here. But on this one, you can see that slower pages are going to have less image caching. We went down from 99 to 91%, so at the 75th percentile page, 10% less. But we still have good caching rates available from JavaScript and other resources here as well. So it's great to have the data for mPulse aggregated directly in mPulse, but also we can kind of pull these up and see specifically what sort of caching ratios we have for CDN caching across different resource types across multiple pages. Some of the other things we do is those dimensions that we mentioned before, where you can actually see the Akamai property version of the HTML protocols. Now you can see what percent of your customers are doing HTTP 1 or 2, and you can compare the performance and use these as filters in your data. You can also compare those pages that have Akamai Adaptive Acceleration enabled versus those that don't. Here you see maybe a 380 millisecond improvement when Akamai Adaptive Acceleration is enabled. The one that would want to focus on the most, though, is this Akamai property versions, because this is an incredibly powerful tool to be able to see the Akamai property version of every page we measure, as well as the performance of every page. So I'm going to pull up another dashboard here called Performance by Group. And what this one is showing us is over the last 30 days, we're going to group this by the Akamai property version, and it's going to show us all the Akamai property versions. And for this particular site, you can see that earlier in the month they were on property version number 78, then they switched to property version number 80, and then for a little while they were on 81, and now they're on version 83. So they've had 4 Akamai property versions in the past month. The follow-up question might be, okay, well, how did it work? Did each of those product configuration changes improve the performance? Well, down below here we have each of those property versions, and you can see the page load time for each. So when we were on version 78, that's this row here, the page performance was 4.91 seconds. When we moved to version 80, and we measured about 203,000 pages that were in version 80, you can see that the page load time actually went up quite a bit. We had a slowdown in the page load time. When we moved from 80 to 81, it fixed it. We went back down to 3.94 seconds, and then when we're going on to 83 here, we don't have a lot of data. We've only got about 5,000 pages measured in 83, but it's about 4.55 seconds. But the important thing here is we now have direct visibility. Every time we make a change to our Akamai configuration, we can see how many measurements there were, what was the load time of the page, and then if there was a change in the performance, you can see was it a change in the performance of the time to first byte, which is the initial request for the page, or downloading the resources on the page. We can even go one step further and take a look to see if there's any other changes that might have occurred on the site as well in terms of page weight. Because even though we're looking at there were changes to the Akamai property version, maybe they made some changes to the site as well. And a key indicator in that might be if there was changes to the number of items on the page or the weight of the page, which we have details for that as well. So now we have direct visibility from mPulse into every change made to the site, and if the change to your Akamai configuration actually impacted the performance and how much, and where was that impact felt. So that's key data. Now this dashboard that I'm looking at, performance by group, this is a custom dashboard that you can create using mPulse custom dashboard capabilities. If you'd like to get a copy, please reach out to us in the Contact Us section here. Go ahead and type on Contact Us, that's me there. Click Send Us a Message, we can get this dashboard set up for you, as well as the CDN dimension metrics dashboards as well, which are other custom dashboards. Let's talk next though about the last thing that the mPulse data provides here, and that's essentially the mPulse data when it's used with Ion specifically. It provides data back into adaptive acceleration, which is a product feature on Ion that allows you to automatically improve performance of your website by using a few different features: server push, pre-connect, and font preload. And let's talk a little bit about what those are. First of all, pre-connect is basically taking the mPulse data, putting it into the Akamai Adaptive Acceleration Engine, and using that data to determine how often it is that a user who loads a certain page is going to have to connect to another domain. And if we find out that there's a very high likelihood that every time a user downloads page A that he has to connect to domain B, we'll put a pre-connect header on that response so that the browser will automatically connect to that domain early without having to parse the whole HTML before it gets to that notice that it's got to connect to the domain. So this is going to save time on connection by pre-connecting there and being ready, so when they're ready to send the request, it'll send off right away. And that's using the mPulse data. The other thing that we will do is we have something called server push, which using the mPulse data, we'll notice that every time a user downloads a certain page, that they always download specific other resources right after that. And if we note that there's a 90% chance that they're always going to download a certain font or something, or a certain image, let's go ahead and send that image with the HTML so that they'll have it there right away. And so that's going to save them, again, the time of parsing that document. Now, important to note is that after Chrome 106, Chrome doesn't support server push anymore, so this is a feature that as we move forward is not going to be available as much, at least for it'll be available on older versions of Chrome and other browsers, but not on Chrome 106 and going forward, but certainly available now, and it'll help by kind of pushing those resources down with the HTML so the user doesn't have to parse the document and download it. Another thing that Adaptive Acceleration does with mPulse data is font preload, which, as I mentioned before, if we notice that every time a user downloads a page, they're always going to have to download this font right away, we can go ahead and send that font preload tag that says go ahead and start to download this font right away, so that you're going to have that font when it's ready. You don't have to parse the document beforehand. And then the last thing that we do with the mPulse data when used with Ion is something called script management, which basically takes all the data that mPulse has about how long it's taking for these scripts to download, and it passes them to Akamai Adaptive Acceleration Script Management, where you can put rules saying if certain scripts are taking too long to download, rather than letting those things block and hold up the page, let's go ahead and defer or block those scripts, or maybe just report on those scripts so that we have visibility into which scripts are slowing things down and potentially blocking resources. So those are the different ways that mPulse specifically has unique capabilities and tie-ins to make your site faster. If you want additional information, please go ahead and see these list of resources. There's a list of metrics and timers that we mentioned before. There's additional details about adaptive acceleration. You can take a look at the server timing support on this link here. And of course, please always don't forget that if you have questions, including wanting to get those dashboards related to custom CDM dimensions, go ahead and contact us, and you can do that through the Contact Us and mPulse. Send a question with the send a message, and we'll be happy to get back to you. These won't be necessarily immediate responses, but usually we'll get back to you within an hour or two with that specific data, and it might save you reading a lot of documentation, which there's plenty of, but not always easy to find. So thanks again for your time. Hope you have a great rest of your day. Appreciate the time.